Good evening, everyone, and welcome to today's lecture. In this opportunity, I will talk about the scientific method. The scientific method is a process for experimentation that is used to explore observation and answer questions. Does this mean all scientists follow exactly this process? Well, no. Some areas of science can be more easily tested than others. For example, scientists that study how stars change as they age or how dinosaurs digested their food. Scientists cannot fast forward a star life by a million years or do medical exams on feeding dinosaurs to test their hypotheses. And when direct experimentation is not possible, scientists modify the scientific method. In fact, there are probably as many versions of the scientific method as there are scientists. But even when it has been modified, the goal remains the same: to discover cause and effect relationships by asking questions, carefully gathering and examining the evidence, and seeing if all the available information can be combined into a logical answer. A method is a procedure for dealing with a set of problems. In science, the scientific method is the strategy for investigation and exploration of the unknown, and the scientific method an objective knowledge of the world constitute the main distinction between science and pseudoscience. Characteristic of the scientific method: it's objective. It's based on facts and not on the subjective experience of the researchers. It's systematic. The scientific method follows a purposeful order. It's a circular process. It starts with observation and facts. Problems or doubts are raised. Hypotheses or tentative explanations are proposed. Experiments are designed and new observations and facts are generated. It's correctable. As results are obtained, errors can be corrected as they appear. It is verifiable. It can be subjected to independent and external examination. It is not rigid. The scientific method is not a rigid and infallible method and can be perfected. Steps of the scientific method. Step 1. Ask the question. The scientific method starts when we formulating a question that we want to answer about something. This question usually starts with how, what, when, who, which, why, or where. And the more important thing about your question is that it must be testable. This means it needs to be something that you can do an experiment to figure it out. Step 2. Do background research. In this step, we find out as much as possible about our research topic and learn from the experience of others. When doing background research, we can find information in many different places. We can use books in the library, search the internet, or ask questions to an expert about the subject that we are exploring. Learning more about the subject helps us to find the best way to do things, give us clues about what data we need to collect, or explain how to set up our experiment. With the information we have gathered, we can move on to step number 3, which is constructing a hypothesis. A hypothesis is an educated guess based on a background research about the answer to our question. A hypothesis always includes a prediction that is easy to test and measure. A good hypothesis allows you to then make a prediction. If I do this, then this will happen. Step 4. Test your hypothesis by doing an experiment. To do this, we first need to identify the variables of the experiment. There are usually 3 different kinds of variables. The independent variable is the one and only that is changed during the experiment. The dependent variable is the one that is measured during the experiment to detect the effects of the changes we are making. Controlled variables are all the other conditions in the experiment that we want to keep the same. For example, the temperature in the room. And you should also repeat your experiments several times to make sure that the first results were not just an accident. Step 5. Analyze your data and draw a conclusion. Once your experiment is complete, you collect your measurements and analyze them to see if they support your hypothesis or not. Scientists often find that their predictions were not accurate and their hypothesis was not supported. And in such cases, they will communicate the result of their experiment and then go back and construct a new hypothesis and prediction based on the information they learned during their experiment. This starts much of the process of the scientific method over again, even if they find that their hypothesis was supported. They may want to raise it again in a new way. Some of the most incredible discoveries in science were made because the data looked wrong. Once you have the data, you may need to perform a mathematical analysis to support or refute your hypothesis. Step 6. Communicate your results. To complete your science fair project, you will communicate your results to others in a final report. Professional scientists do almost exactly the same thing by publishing their final report in a scientific journal or by presenting their results on a poster or during a talk at a scientific meeting. Finally, to conclude this talk, I would like to emphasize the importance of research in that it has been a key instrument for the progress of humankind. We must keep in mind that research is not limited to science. All areas of knowledge are subject to constant research. This is how progress is made. Thus, in economics, education, law, and even art, research stimulates the development of the professional progress. Thank you, and we'll see in the next opportunity.